PCN tours the Keystone State, taking you inside Pennsylvania's factories, museums, and historical sites.
Hello, my name is Mike Sager from Chop-Rite 2. Today we're going to show you how we make our product from the beginning to the end. First of all, we have all our choppers here. This is a number 12 chopper. This does small portions of meat. Then we'd have the number 32 chopper. That's our largest chopper. We have a number 3, a number 5, a cherry stoner that takes pits out of a cherry, number 27 juicer, a number 10, and a 35 stuffer. The company was founded back in the late 1800s and was called Enterprise. In the mid-1900s, it changed hands and it was called Chop-Rite Manufacturing. In 1991, it was purchased again and is now called Chop-Rite 2. Here we are at Ephrata Manufacturing, where they make our castings for our facility. This is what you call a shell core machine. This takes resin-coated sand and hot heat and air that flows into the core. And they call that the heated box. Here he's scraping off excess sand on the shell core. This period takes about 60 seconds through the cycle time so that it gets heated up and cools down, and we can release the mold, and then you have your shell core. Every casting that has an ID inside the casting has to have a shell core or a sand core. This now rotates and gets any excess sand, and it falls out through the shell core. You would scrape off excess sand. And when the time comes, the machine will open up and the sand core will be finished. This machine, you can set the temperature of the heat and the pressure of the sand as it's being flown in to the shell core. Now as it's released, the shell core is complete, and he will scrape off excess sand on the shell. And he repeats this process for as many castings that need to be made. And that's a complete shell core. Then from here, these will get transported over to the molders. Here's where we get the impression in the mold. He puts these are what you call flasks that hold the outside of the mold. He shakes down sand that is mixed, and he's ramming the sand right now. He moves the sand around on the top, and he puts a board on top. That helps pack it, flips it over. Now he puts standoffs inside there on the mold to help. That'll help hold the sand core from shifting. That's the cope side of the flask. You have to ram this on both sides to help keep the two together. Then he puts his board on there. This is what's called squeeze mold. After that squeeze, that gives you the impression of the pattern. Now it's into the mold. This is the screw hole. The screw hole is for where we fill the casting with metal, and the other is for a pop-off. It's where excess gas and metal flows when you know you have the pores filled. You have to blow off every time so you don't have excess sand into the mold, or you get a defective casting. They have air vibrators to help pull off the pattern. these are another core that they put in to get the impression of the bottom of the foot on the casting. Here he is putting in the shell core that you just seen made. Now on the shell core, the core sits in here and you have the thickness of the material that would be poured, so you have the wall thickness of the casting. Places the coat back on, then he will take off the flask. He takes a filter, a ceramic filter, that is filtered the hot metal when it gets poured in to make a casting. It takes out any impurities in the metal. This is a cubulo. This is where the iron is melted down roughly 2,700 degrees. When it's melted down, it flows down the trough and into the ladle. Or they will bring over the bull ladle, which will carry the iron, melted iron from there over to the floor where it's going to be poured. The excess spark that you see flying out of the cubulo is slag. They have a tilt table that they can transfer from one side to the other side. Here's where they also scrape off, they skim the top off for any poor metals that are on top of the metal, or dirt. The electric furnace to the right is where they can store it and also pour it out of if they have extra metal waiting to be to the positions where they want to pour castings from. Here we will be pouring melted iron out of the furnace into the bull ladle, which will be transferred up to the molds where we'll be pouring the castings. It's very important that you wear face protection, leather protection on your legs. This is roughly 2,700 degrees of melted iron. Transferred. That's excess slag that is bouncing in the air. Here he will skim the top. This takes off any impurities in the metal that come to the surface. He closes the lid and it's transferred up. the 60-pound hand ladle, then which will be poured into the molds. Here he will also skim the surface again. Here you see him, he will be pouring into one of them screw holes with the filter. And the other screw hole is for excess gas. And material will rise to the top of excess run-out material. This process is repeated down the line. Once they have one row poured, then they'll do like a shift and they'll take the jackets and the weights and move them back to the next row to be poured. After these castings are poured, they'd have to sit roughly 10-15 minutes before they're broke apart. That varies on the different size castings you're getting poured because of the cool down time of the material. And that's a very critical point of making a casting. After they sat for roughly 15 minutes, the molds are dumped over and your casting comes out. This is very critical point of the casting because if they sit not long enough and they're dumped, you get hard spots in the castings and then you cannot machine them. So this is a very critical point of making the casting that you don't get hard spots. After they dump the molds, they knock the gates off the castings. The gates is where the metal was poured down into the screw holes to form the casting. Then they put them in carts. From there, they get transferred over to the spin blast room. And after the sand is dumped from the molds, they recycle that sand and they use it over and over. And the excess iron that's on the ground, they can recycle that too and remelt that down. This process is done all day long as you're making castings. As you can see, a lot of this stuff is heavy lifting and hard work. That's how to get a lot of the excess sand off, is by flipping them around and keep moving them. And they take the hammers and they hit it and it helps get the excess off and the gates off. Here we are at the spin blaster. This is where the castings come to get cleaned. When they're broke down and broken apart over there, they're very black and dirty. Here they're put into the spin blaster. The spin blaster rotates around and they have shot peen. You can see the shot peen metal abrasive that's blown into the casting and on the casting. Here you can see is where it gets shot peen. Inside and out the metal goes. You have to physically rotate the pieces as they come around and do a visual check for when you should be rotating them to the other side. This process, it varies on the time due to the size of the castings. Where your one core was, where it was in the bottom of the foot when you see him when he was pouring the metal over at the molders. This will all get ground and knocked off, but you can see how it has to contour. This is where that shell core sat inside and gave you your ID of your casting. Some of the castings still have the standoffs to hold the shell core. They will all be removed and ground off clean. That'll be the next process when we go over to where the grinding room is. Here we are, where Rick will be inspecting the castings, and he checks for any defective castings or blowouts. He knocks off the heavy gating and the fins on there. This is a very critical point to check the castings to make sure there's no defects. Then from there, they'll go over to the grinder. Some of the grinding will be done at this grinder right here. See where they had ground the top fins off, excess metal around the top. This will be done at another station where it'll be grinding over on the other side. But it's very important that when we grind, So we grind this off, and you don't grind too much off that it defects the casting. From here, we'll go to another grinding station. Here the castings go over to where they run them on an air grinder. Here the castings will be ground on the insides of the legs to get all the excess metal off. This is where an air grinder comes in handy because the pedestal grinder can't get in all the nooks and crannies. This is where they're ground down with air-powered tools. They have a downdraft air system that sucks the grinding grit down into the air system. These grinders, the air grinders, are roughly about an 8-inch air grinding. He will also grind it, and as they're grinding, they do look for defects in the casting. After the castings are ground, then they are weigh counted and ready for pickup so we can transfer them to our facilities in Harleysville, PA. They weigh count all the castings, that way they don't have to physically count each one. We're now at Harleysville, PA at Chop-Rite 2 facility. We're going to show you how we do the inside taper boards of the casting. Today they're running off number 12 bodies. The first operation of that is we spot face the side of the chopper here. And the operation he's doing now is he's counterboring the bottom of the chopper and running the tapered reamer inside. The tapered reamer takes out any excess material that is in the body of the chopper. And it gives you a taper for your feed screw to fit down in. As you can see, the reamer is on a taper, and it has a counterbore in the bottom, and also a reamer to go through where the feed screw would spin. That operation, as you can see here, I'll hold a piece up, puts in that spot face in the body of the chopper. This is one of the procedures that we're talking about out at the foundry, where if the castings are hard and they knock the castings out, this is where we cannot machine them because the castings are too hard. And it's very critical that the castings are not hard. Then from this operation, we go over to the CNC lathe. The CNC lathe is where everything is done automatically. He's now chasing the threads on the outside of the casting. He'll now shut the machine off and change his piece. change this tool. First operation, it'll come in and it'll face the body of the casting. Next, it'll do the turning operation, where you get the right diameter, then you can run your thread. This is critical that the diameters are within tolerance, because if the OD and the threads are out of tolerance, then the feed screw, when it gets in place, when the feed screw is placed inside and you put the lock ring on, it doesn't lock up, or you have a sloppy fit for the ring. The boring operation is where the chopper plate fits inside the bore. Now we'll thread the body. This is also critical that the root diameter thread is the proper size. I'll deburr the face of it. We'll use the thread gauge to check, make sure that the threads are the size. Take your sample feed screw with the anti-friction washer on it, the knife, and the plate to make sure that we have the right tolerances inside the body. You take your veneers to check the depth of your bores. To make sure they're within tolerance on the drawing. This is where the castings are drilled and pinned. This is where the pin goes in to keep the plate from rotating when the chopper is being cranked. Next step is drilling the feed out. These holes are where you mount the chopper onto a board or onto a fixed mount to hold the chopper while you're cranking. Got the 4 holes in the feet. And then the pin to lock the plate. This is where Russ will be inspecting the castings and also blowing out any excess dirt in the body. From here, they'll go and get Xylon coated. Here we are where they're going to put the bodies on the cart and they're going to roll them into the oven and pre-cook them at 400 degrees for roughly 20 minutes. This is what takes out any excess dirt or any oils that are in the casting before we do our coating. This is very important that they're pre-cooked before they're coated so that the Xylon sticks to the casting properly. The oven's set at 400 degrees within 10 degrees fluctuation. And these will be baked for roughly 20 minutes. After 20 minutes are up, we open up the oven, we bring out the castings. Here he leaves them cool down to room temperature and then he'll coat them. You can see that this color of the casting when it comes out of the oven, how it's not just gray colored anymore. It has light spots and dark spots. This is Xylon coating, food grade. It's sprayed on. Gets sprayed on just like painting any other kind of paint through the gun. After it's coated, we put it in the oven at 350 degrees for 15 minutes. That way the Teflon or Xylon coating is properly cured onto the casting. These are the feed screws that are already coated and ready to go into the oven. They're placed in the oven, the door shut, and they're baked for 15 minutes. Here's where we have the bar in the horizontal mill, and we're putting the groove in where it catches the pin on the inside of the body. This is our first step of making the plates. Here we are at the automatic saw, where the piece is put in there and it's automatically fed up to the stop, and the saw cuts it automatically, retracts back up, and the piece is extended out to the stop, and it's sawed automatic. This repeats itself. You can set the piece counter on the machine for how many pieces you'd want cut. This step here is where we're putting a chamfer on the outside of the plates. You do one side, you turn it around, do the other side. The next step is putting the center hole in. This keeps any sharp edges from on the plate. The next operation he's doing, he will be putting the center hole in to go onto this hole. That's to go onto the feed screw, onto the stud. Once this operation is done, they go back to the grinder. This is the part that's getting ready to be ground. You can see the saw cut marks in it. When he's done grinding it, this is what it will look like. This way it sits parallel in the device in our next operation. Here he'll be grinding the plates. He's roughly taking about 10 thousandths off per side. 10 to 15 thousandths. We pump a coolant on there for lubrication to keep the tool and the part cool. The table where the part is sitting on is rotating counterclockwise, and the grinding wheel is rotating clockwise. That's how you get your ground effect. This procedure is done twice. It's ground before it gets drilled over in a CNC, and then after it's drilled out, we send the parts out to the heat treaters. This is the next step where they're put in the air vise and the CNC mill drills them automatic. These are the 22 plates with a 3/16 hole. And every plate that has different sizes, we change the drill bit to change the size holes in the plates. When the plates are drilled, this is what they look like. When they come back from the heat treaters, this is why we have to go back and grind them again to take off any excess burrs, and it keeps the holes sharp so when a knife rubs against there, it cuts the meat when it's forced through the plate. As you can see, we have the number 32 body here, the feed screw, the ring, the plate, 3/16 hole plate, knife, the anti-friction washer, and a handle. At this point, quality control will pick up the part, inspect it again, and assemble the chopper and make sure it spins freely and ready for shipping. It's important when you assemble these that you put the anti-friction washer in onto the feed screw, because that keeps lubricant from the meat into the body of the chopper, and it doesn't build friction up in that as rubbing two pieces of metal together. And we put the back nut on, what we call ring. As we were saying when we were boring these out, that's important, and threading, that everything fits to the proper sizes. Product's ready to go in the box and fulfill an order. Back at the boring mill, this is where we bore out the 35 stuffer. As he's taking one of them off, we can look at a raw casting that came from Ephrata. You can see how the inside looks before we bore it out. This operation is critical because the bore has to be true and to size, so when the top arch and the plunger plate goes in here, we only have to have a couple thousandths, roughly 3 to 5 thousandths clearance on the side, so the meat does not ooze up and around. We'll be putting a stuffer tub on the mill, lining it up. Every operation is critical. This one here, we take a plate, a smaller plate, to line up the rough bore so it bores true and to size, and it's critical that the bore is the right dimension from the holes, which would be the next operation for drilling, to the tub. Don, roughly how long does it take you to bore one of these tubs out?
It takes about an hour for the two bores. Roughing bore and the finish.
After he gets it in place and locks down, he'll rotate the head and start boring out the tub. As you can see, he has an indicator up top here so he knows where its location is. That can be done precisely. This is where he drills out for the feet. After he drills the feet out, then he does the top holes for the arch and taps the bottom. While he was drilling over there, this got finished being bored. And what he'll do now is he'll take the inside mics and check the bore to make sure it's properly the size. After he checks the size of it, and that's a critical point of the stuffer because, like I said, it has to have the clearance of the plate and the size of the wall of the stuffer. He'll rotate his tool and he'll chamfer the top lip for the lead for the plunger plate to go into the stuffer. Go down to the depth that he needs to be. And you can see the top chamfer that it put on. And that's what gives you your lead for when the top plunger plate goes down into the body. Here we're making the basket for the number 35 stuffer. It's a 304 stainless steel perforated sheet material. Has the holes already perforated in it. After he rolled it, he'll take it on the anvil and he'll put the hems together on there and seam it. This is important that they're together properly because after he locks them in, he crimps the ends with a hammer and punch. If that's not done properly, the basket will come apart. We'll tap that around to keep the shape and the form of that diameter. From there, he'll spot weld the handles on. And it's important that he gets the handles on the right side of the basket because you can see we have a piece of wire, 093 wire, crimped in on the outside roll, and we also have it on the inside roll to keep the inside one keeps the strainer basket or strainer plate from falling through the bottom. He takes over the spot welder, and it's automatically timed and set for heat range to spot weld on the basket. And it's repeated to the other side of the basket. The heat range ain't set at the right temperature and the timer, it'll either burn through the handle and it'll leave a bad, it'll burn out through when you have a hole, when you have a reject, or if it's not, the heat ain't set right, the handle will come off. That's why it's important to set the machine right. And then you got your end product of the basket. And they're ready to squeeze their vegetables through it, tomatoes. Here we're going to be putting the stuffer together, which we walked in halfway. It's already assembled half the way. You already assembled the rack screw and the large cog, small cog, and the plate. which then he'll put them on to the 35 body tub. And as we said earlier, it's very critical that the bore, that the bore is bored true and to size, so the plate has the right amount of clearance when it plunges down in there, that the meat does not ooze up in the out and around the side of the plate. And if it was bored too big, the meat would ooze out, and too small, the plate would not plunge down into the tub. You have a set screw in the side arch, so when you rotate the top arch to open and close it, it doesn't work the bolt loose. This is where he'll crank it down and make sure everything fits and seats properly. He'll crank down by hand to make sure it starts, but then he'll use the tool to save time for testing it up and down. He'll run that up and down several times, and then he'll also take that off and do it by hand. And you have an oil here where you use vegetable oil for lubricant for that to rotate around. And this is where the basket would be in place with a smaller plate and a basket, and it would press the juice out the spout. As you can see, here's one with a basket in it and a smaller plate, plunger plate. And that's where you'd put like your tomatoes in there. And all your juice would run out the sides. And the seeds could not go out through the hole, or the large parts of the tomato couldn't go out the bottom. This is a spout holder. This is where you'd put your casing on. You slide your casing on, and your meat would come through here to make your sausage to go into the casing. And you have different size. You got the standard plastic 3/4 inch one that comes with the stuffer. And you have other aluminum ones with different size, 3/8 up to 3/4. And they just stick in here. You lock that on. This includes our tour today of Chop-Rite 2. Everything is made in Pennsylvania. If you'd like more information on us, you can visit our webpage or call us. Thank you.
Teachers are welcome to record PCN tours for use in the classroom. If you know of a Pennsylvania manufacturer or museum you would like to see on PCN, call us at 717-730-6004. Please include the name of the company and the location. Videotapes of PCN tours can be purchased for $29.95. To order, please send a check to the Pennsylvania Cable Network, 401 Fallowfield Road, Camp Hill, Pennsylvania, 17011. Please indicate the PCN tour you are requesting and include a shipping address and phone number. Prices are for PCN tours only. Tours, books, and profiles. Every Sunday night on the Pennsylvania Cable Network. At 8, PCN tours Pennsylvania manufacturers and museums. At 9, PA Books, interviews with authors on Pennsylvania topics. And at 10, PCN profiles prominent Pennsylvanians. Check PCN's website for this week's tour, book, and profile.